Example 3. A person deposits $3,000 at the end of each semi-annual period into an account earning 9.6% compounded semi-annually for a period of 15 years. Determine the value in the account 10 years after the final deposit has been made and the interest that has been earned over the 25-year period. Let's do a quick analysis of what we do know. We know that the payments are $3,000 per semi-annual period, so that means every 6 months we make a deposit of $3,000. And we also know that the interest rate is 9.6% compounded semi-annually. And when I break that down into the rate per period, I've got 9.6 divided by 2, or 4.8%. So I is equal to 4.8% per 6-month period. We also know that they've been making semi-annual deposits for a total of 15 years. So the number of deposits is 15 times 2 deposits per year, or a total of n is equal to 30 semi-annual deposits. So on our timeline, we can show that we've got 1, 2, 3, all the way up to 30 semi-annual deposits of $3,000 every 6 months. So we've made 30 semi-annual deposits of $3,000 at the end of every semi-annual period. So our time diagram for the annuity really is a 15-year term. So here's our annuity bus, a 15-year term, n is equal to 30 deposits, so our 15 years. Now the question says, determine the accumulated value at the end of the 25 years. So in other words, what we really want to know is how much is in the account at the end of 25 years. We can't do that right away. What we're going to do is we're going to break this up into 2 problems. The first step will be to determine the maturity value, or the final value, of the annuity of the $3,000 deposits. And so that's going to include all the deposits plus the accrued interest. So we're going to take the $3,000 per 6 months and multiply it by the annuity factor, which is 1 plus 0.48% per 6-month period, 30 semi-annual deposits, so the exponent is going to be 30, subtract 1, divided by 0.048, and multiply that by the factor by the payment size. When you work this out on your calculator, this amounts to a value of $192,604.72. We'll round that off to the nearest penny. What's absolutely important here, but quite critical, is that you know when or what time period this has a value. This value of $192,000 is the value at the end of the last deposit, at the end of the 15th year. So on our time diagram, we're going to locate that. It's $192,604.72. So the final value of the deposits at the end of the 15th year is $192K. Now, if we want to determine how much is going to be in the account at the end of the 25-year period, what are we going to do for that amount? Well, what that means is that our focal date is going to be at the end of 25 years. And if our focal date is here, we're going to be multiplying by the compound interest factor. So we no longer have an annuity anymore for the last 10-year period. For the last 10-year period, we actually have simply an amount of $192,000 earning compound interest. So we're going to use the S is equal to P multiplied by the compound interest factor for the number of periods. And so we're going to use a compound interest factor of 1 plus I to the exponent n for that 10-year time period. So in this particular case, the maturity value is going to be equal to the initial value of $192,604.72 multiplied by the compound interest factor of 1 plus 0.48 raised to the exponent. Well, let's see, it's semi-annual periods, and we've got 10 years. That's a total of 20 semi-annual periods, so the exponent is going to be positive 20. And so we end up with a maturity value, or the accumulated value at the end of the 25th year, or 10 years after the last deposit, of $491,000, $491,917.85. at year 25. Wow, that's a large amount of money, $491,000. Keep in mind that now we can easily answer the question of how much is the accumulated interest, or how much interest was earned for these investments. And the interest is simply the difference between what we put in without interest and what we have at the end of the period with the interest. Without the interest, let's see, without the interest, we have a total of 30 deposits of $3,000. So we've got 30 deposits of $3,000. That amounts to a total of $90,000. With interest, after 25 years, we have a value of $491,917.85. It stands to reason then that the interest that was earned over the 25-year period is simply the difference of $401,917.85. So the accumulated interest is more than 4 times the amount that went into the account.